Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so today we are going to discuss why matter, or rather we can say elements, react. So we have already discussed about the atomic structure, electronic configuration of first 20 elements, and we have seen the classification of matter also. So all these things have been discussed. So today our main topic of discussion is why matters react. Why matter react. So this is our main topic of discussion for today. So see, as you have seen, if you have considered, if you have seen the electronic configuration of the first 20 elements, and among those there were three noble gases. Helium, first one is the helium, having atomic number 2, having a configuration of only like this. Then there was neon, atomic number 10, having a configuration something like this, 2 and 8. And then it was argon, having an atomic number 18, configuration having something like this, 2, 8 and 8. So as you can see that the noble gases are stable in nature, that is, they do not react, they do not ordinarily react. Under some very special cases, only a few noble gas, xenon and krypton, these noble gases react, but under very specified condition, very rarely. So in neglecting that special case, if you consider that the noble gases are stable, that is, they do not react. Now the other elements also try to achieve their stability that the noble gases have. So if I consider the criteria for stability, you see, other than the helium, neon and argon have 8 electrons in the last shell. Obviously helium has only 2 electrons in its one shell only, that is the last shell. So this 2 electron in the last shell or 8 electrons in the last shell can be considered to be as a token for stability, as a criteria for stability. So if you observe, I think you have seen the class on the electronic configuration. If not seen, please do watch those videos. So you have seen that the other elements has electronic configuration where the last shell do not have 8 electrons, rather 1, 2, 3, 4, 5, 6 or 7 electrons, like this. Now I am said one sentence in the previous class I think, that every element, atom of every element tries to attain the electronic configuration of its nearest noble gas. So if I consider the element, say sodium, now this element sodium has a configuration of, it's an atomic number 11, configuration of 2, 8 and then 1. Now the nearest noble gas of sodium is neon, so sodium will try to attain the electronic configuration of the neon, isn't it? So how it can attain? Definitely, if sodium just expels out this one electron in its last shell, then it will be having a configuration similar to that of the neon. So the sodium atom, on releasing one electron, now this will form a sodium ion. Now what is ion? Ions are the charged atom. You have already read this concept. If not, then for those who are new to this word, ions are nothing but charged atoms. Okay, charged atoms. In general, we have said that atoms have equal number of protons and electrons. Okay, but under certain cases, if the atom gives out certain number of electrons or accepts certain number of electrons, then they become charged. So basically, what are ions? I am just writing it here. Ions are charged atoms. Now the charge can be positive as well as negative charge. So these are charged atoms. Fine. So when sodium gives away one electron in order to become stable, in order to achieve the electronic configuration of neon, why they want to achieve the electronic configuration of neon? Because they want to become stable, and for that they give away one electron and then they become 1 plus. Why I am writing this 1 plus? Because here gave away one electron, so it has now one excess proton in it, and thus the sodium atom has overall one positive charge, and this is regarded as a sodium ion. So by forming sodium ion, the sodium atom becomes stable. Okay. Likewise, if I consider say chlorine, it is an atomic number of 17, configuration of 2, 8 and 7. So now it wants to attain the electronic configuration of the nearest noble gas argon. So how it can achieve? It can receive one extra electron from wherever it may be. It can receive one extra electron, and then this becomes this last shell. Then we will have 8 electrons as that of the argon. Okay. Now as chlorine has gained one electron, then chlorine becomes also charged, and I can write Cl 1 minus. Why 1 minus? Because it has received one electron. So now it becomes negatively charged, and this is an ion. So chlorine atom gains one electron to form a negatively charged ion to attain stability. Can you say it? Yes. Okay. So basically what you are seeing, that when the atoms of the different elements other than this noble gas wants to attain stability, they either give away electron or take electron, accept electron. These are the two ways. There is also another way where electrons are being shared between two atoms. We will be not discussing that in today's class. In some later class we will be discussing that. Okay. So two ways of attaining stability. Now when they are giving away electron or accepting electron, what happens? Chemical reaction takes place. Okay. So electrons are exchanged, and when electrons are exchanged, basically you can say that chemical reaction is taking place. So that is why I think by now you are clear why different elements, why different matters, different forms of matters react to attain stability. The ultimate goal is to attain stability. Okay. So you can say, so I am just erasing it off. So you can say that atom of elements other than noble gases attain stability. So atoms can attain stability. Atoms can attain stability mainly by three process. Okay. First process is give away electron. Okay, give away electrons. Okay. Then second process is accept electrons. Accept electrons. Okay. And third process is sharing of electrons, which we will be discussing not in today's class but in some later class. Sharing of electrons. So these are the three processes. Now electrons are generally given away by metals. These are generally given away by metals. Okay, the metallic elements. The accepted electrons are accepted by generally the non-metals. Okay, and sharing is also done by the non-metals. Okay, non-metals. So these are the ways by which atoms of elements other than noble gases can attain stability. Okay, so is it clear? Fine. Thus we think the concept why reactions occurs is clear to all of you. Now you can easily understand the concept of reaction in details. Okay, fine. Now the metals generally give away electrons. How many number of electrons they generally give away? They generally give away 1, 2 or 3 electrons, because they have either 1, 2 or 3 electrons in the outermost shell. Non-metals generally accept, how many electrons they will accept? Either they will accept 4 electrons or they will accept 3 electrons. The non-metals which have 4 electrons in the outermost shell will accept 4 electrons. Non-metals which will have 5 electrons in the outermost shell will accept 3 electrons. Non-metals which will have 6 electrons in the outermost shell will accept 2 electrons, and non-metals which have 7 electrons in the outermost shell will accept 1 electron. In this way they generally attain stability. Okay, and sharing is generally done by sharing of either 2 electrons, 4 electrons or 6 electrons, like this. Okay, so sharing can be, we will be not discussing that today, so I am not saying much about that. Okay, so this is how the atoms attain stability. Okay, with that we come to the end of our brief class today. Now in the next class we will be discussing about valency. Okay. Till then, please do watch these videos and make your concepts clear. If you have any problem, mention it in the comment box. We'll be happy to solve your problem. Thank you. Goodbye.